tell you about the geologic history of New York that produced these rocks that we see here in Central Park. Now, the story goes all the way back to 500 million years ago. 500 million years ago, this place was 20 degrees south of the equator. Right now, we are about 40 degrees north of the equator. So, 500 million years ago, this place was a shallow seafloor collecting sands and clays and shells. And those sands and clays and shells, those sediments turned into sedimentary rock, rocks like sandstones and shales and limestones. And then around 400 million years ago, the situation changed. This place became an active boundary because an island arc came and collided with this part of North America, this edge of North America, and collided with this land and folded up the sedimentary rocks, squeezed them, and built mountains here. And the two land masses became one, joined at the suture zone where these mountains formed. This mountain building episode that sutured the two continental blocks is called the Taconic orogeny. And this was followed by two more mountain building episodes, the Acadian orogeny and the Alleghenian orogeny. As a result, a huge mountain range formed here in this very spot. And that mountain range extended all along the eastern edge of North America and sutured three big continental blocks together, creating the supercontinent of Pangaea. So the place where we are standing right now is where that suture zone is. And at that time, the Appalachian Mountains that resulted from these three collisions was as high as the Himalayas are today. But today, when we look around us here at all the rocks, we don't feel like we're on top of the Himalayas. And that's because for 260 million years, since the ending of the mountain building episodes, this whole region has been eroding, and all the top layers have been eroded off, and the core of the mountain range, the root of that mountain range, is now exposed. So we are standing on rocks here that were formed in the core of that mountain range in the Paleozoic time. Today, 260 million years after that, these rocks are now exposed, and we can walk over them and see these high-grade metamorphic rocks which should not be at the surface. They're only at the surface because the top layers were eroded off. So these high-grade metamorphic rocks that we're standing on formed deep inside the mountain range at very high temperatures and pressures. And it's the pressures that created this foliation that we see all over the rocks in Central Park, metamorphic layering.